Holy moly. Excuse me. Lesson 2, you're solving inequalities. So you're just graphing these on number lines. So, like this one, I got x greater than or equal to -1. So I put my -1 on my graph. I put a 0, I put a -2. Greater than or equal to means I'm going to have a closed circle. That's what that equal to part means, that extra line on the bottom. And greater than goes to the right. X is less than 2, so I put 2 on my number line. Let's go a little above it, a little below it. Less than, not equal to, so you leave it as an open dot. And less than goes to the left. Here we got one that's sandwiched in between, so we want to put both numbers on there. So -1, 0, 1, and 2. And they're both open circles. And since it's sandwiched in between these two, that means you're just connecting the two. When you got that or in there, you have two different things, and they're going in opposite directions. So, -2, -1, 0, 1. At 1, I got an open circle, and I'm going to the right. It's greater than. -2, I got a closed circle. I got that equal to part, and it's less than, so I'm going to the left. Solving equalities reminders. Number 1, you want your variable on the left. You want that variable on the left. Number 2, you're going to solve as usual. And number 3, if you're going to multiply or divide by a negative number, you have to switch the signs. The sign flips. So let's do this one. So we got 7x over here. I want variables on the left. That was my first rule. So I'm going to subtract it over. So I have -12x plus 2 greater than or equal to -4. I've got to bring this number to the other side. I got -12x greater than or equal to -6. Now when I divide by -12 here to get the x by itself, that variable, this sign here, is going to flip. So now x is less than or equal to 1/2. You have $50 to spend at the state fair. You spend $13 on admission. You want to play a game that costs $1.50 each time you play. Write, solve, and graph an inequality to model the possible number of times you can play. So you have $50 that you can spend at the fair. You spend $13 on admission. And then each time you play this game, so there's our variable, each time costs $1.50. Now what inequality goes here? Well, this, you're adding how much you got in, and your game cannot go over 50, so that's got to be less than or equal to. Then we're going to solve this thing. So we'll subtract 13. I got 1.50x less than or equal to 37. Divide by 1.5, and I got x less than or equal to, I think you get 24.67 repeating. So how many games can you play? Only 24 games. Can't play 25, but you can play 24. Might have some change left over. Solve and graph. So this is one where it's sandwiched in between. So it's just like how you do the other one. You just have 3 different sides to it. So you're going to add 10 to each side you do. So now in the middle, I just have -6x. Oops, that one's just less than. I got 6 and 24. Then when I divide by a -6, I have to flip my sign. So this one becomes this way. And I got -4 and -1. And if I'm going to do a number line here, got -4, -3, -2, -1. -4, I got a closed circle because I got that equal to. -1, open circle. And since it's sandwiched in between, you just connect them. When you have the or, you're doing just like you normally do. But when you graph it, you're going to have 2 things going in opposite directions. So here we got 5x minus 10 less than -12. I'm going to add that 10 over. and divide by 5, I get x less than negative 2/5. Nice small number there. Or, when I subtract my 5, I got 1/3 x greater than or equal to 4. And to get rid of this 1/3 here, I'm going to multiply by 3. So that goes away. So, or x greater than or equal to 12. This would be your answer. And again, when you graph it, they're going to go in opposite directions.